Hi again, everyone. Chris Tisdell here again. Thanks for tuning in. In this presentation, I am going to continue my live streams on linear systems. And in this particular video, we're going to talk about 3 equations and 3 unknowns. In previous videos, we talked about 2 equations, 2 unknowns, 2 equations, 3 unknowns. So now we're going to the next step. Now, geometrically, we are looking at 3 planes. So the question is, how do those planes intersect at all? What does the geometry look like? All right, so I'll show you some examples in a minute, but these are kinds of linear systems. And there's a number of outcomes with the solution set. Okay, first of all, there's no solution where the planes might be parallel, but they're not identical planes, or they don't touch in the same spot. There's one solution where 3 planes can align at a unique point, or there's infinitely many solutions where the planes touch jointly along a common line. And the fourth situation is where there's infinitely many solutions, but the planes are identical. They're just, the 3 planes are just lying on top of each other. Now, let me bring in some visuals and show you how it works. So first of all, let's talk about no solution first. Let me see if I can bring this in. Okay, so here, the gray area is the XY plane. The blue axis is the Z axis. So here I've plotted X plus Y plus Z equals 1. Let's bring in another plane and another plane. So you can see if I rotate this a little bit, 2 of the planes are parallel. Now they definitely intersect with the third plane, but not along a common line. Okay, so this is a situation where there's no solution. Okay, the planes intersect in some way, but they're not touching, in this case, along the same line at the same point, or at the same point. Okay, all right, so let's get rid of those ones. What about this plane and this plane? So you can see they cut along a line, and then let's put in a third plane like that. So you can see they're definitely not touching at the same point. So that they do, 2 of the planes intersect with each other. But if I take that one off and put that one on, what happens then? Okay, well, you can see that, if I can get to it, let me pull this up a bit. Hang on, I'm a bit out of control here. Come back. All right. So you can see down here, there's the point of intersection. Okay, that line of intersection lines up with that line of intersection. So there is one solution. The planes intersect at a single point. Okay, and what about, say, when the planes are identical? Well, there you go. It's just one plane, and in fact, GeoGebra has simplified the algebra there. So if I take that off, it gets a bit lighter. If I take that off, it gets a bit lighter. Okay. Now, what I haven't done here, I haven't shown you a line. I don't think I've shown you a line of intersection. Let me just type in one of those. Okay, so I'll take that off, and I'll see if I can. Okay, so I'm back in there. So let me just do a simple line of intersection. So I'll take x equals 1 with x plus y equals 1 with, oh, hang on, let me adjust that. X plus y equals 1 with x minus y equals 1. Okay, so what does that look like? Okay, so you can see there's one line of intersection there. It's just here. Okay, this vertical line. Okay, so that would be the situation where there's infinitely many solutions. The solutions lie upon a line. Okay, so hopefully that's given you some insight into the situation. Oh, I see. I see John Yang's back. Hello, John Yang. I'm your student. You're in holiday mode. Great, so am I. I'm just reading some of the comments. Sergeant Soap says, unlucky you're streaming while I have an exam. Thank you very much. Good luck with your exam, Sergeant Soap. And FS Stephen, looks like you're getting ready for linear algebra college in the next few minutes. I'm glad that you are going to watch this later. Now, Sergeant Soap, I will get back to see if there is a Math 1231 stream before the final. I will definitely do that. Let me just type something in here. Hi, everyone. Thanks for the comments. And Sahej Singh. I'm okay. Anyway, so let me just get back to what I was doing, right? So, 4 situations. There's either no solution, the planes are either parallel or they intersect, but not simultaneously, say, on a plane or on a line or at a point. Okay, so they're non-identical planes. There's one solution. The planes cut at only one point. There's infinitely many solutions along a common line, or the 3 planes are identical and they sit on top of each other. Okay. All right. So it's holiday time here in Sydney. I'm about to go on holiday. Whatever you're doing, I hope you're having a great time. If you're doing mathematics, have fun with it. If you have any comments, any questions, I would love to hear them. See you later, everyone. Put your comments in the comment section, and I'll see you soon. Bye.